At first glance, the idea that 0.999 repeating is exactly equal to 1 feels like a mathematical trick. Our intuition often tells us that no matter how many 9s we add, we are always just a tiny bit short of reaching the whole number 1. However, in the world of mathematics, this isn't an approximation or a rounding error. They are actually two different ways of writing the exact same value. To understand why, we have to look at how we define real numbers. Between any two distinct numbers on a number line, there must be another number sitting between them. If you try to find a number that is greater than 0.9 repeating but less than 1, you will find that it is impossible to do so. Because there is no space left between them. They must be the same point on the line. One of the most common ways to prove this equality is by using simple algebra. Let us start by assigning a variable, x, to the value 0.9 repeating. If we multiply both sides of this equation by 10, our x becomes 10x and our decimal shifts one place to the right, giving us 9.999 repeating. Now, here is the clever part. We can subtract our original equation from this new one. 10x minus x leaves us with 9x. On the other side of the equal sign, 9.9 repeating minus 0.9 repeating leaves us with exactly 9, because all those infinite decimal places perfectly cancel each other out. If 9x equals 9, then dividing both sides by 9 shows us that x must equal 1. If the algebra feels like a sleight of hand, we can look at it through the lens of fractions. Most of us accept that the fraction 1/3 is represented in decimal form as 0.333 repeating. If we take 3 of these fractions and add them together, 1/3 plus 1/3 plus 1/3 equals 3/3, which is exactly 1. Now, let us do the same addition with the decimal equivalents. 0.3 repeating plus 0.3 repeating plus 0.3 repeating results in 0.9 repeating. Since the starting fractions equal 1, and the sum of their decimals equals 0.9 repeating, the two results must be identical. This demonstrates that our standard system for writing decimals can sometimes produce multiple names for the same numerical value. For a more advanced perspective, we can think of 0.9 repeating as the sum of an infinite geometric series. This means we are adding 9/10 plus 9/100 plus 9/1000, and so on, forever. In calculus, we define the value of such a series as the limit it approaches as we add more and more terms. As the number of terms goes to infinity, the sum doesn't just get close to 1, it reaches 1 as its limit. This is a fundamental property of the real number system. We aren't just adding 9s until we get tired, we are defining a value based on an infinite process that concludes at the number 1.